Okay, we have day 2 of 11.2, and what we're looking at is the third page of our 11.2 notes. Cylinder is a solid that has two congruent parallel bases that are circles. Keep in mind, two congruent parallel bases, if I can actually get these going, they go all the way through, and it's that elevator idea again, okay? If it goes cleanly through the shape of a prism, that's the base. Now, an altitude of the cylinder is a perpendicular segment that joins the planes of the bases. Height h of a cylinder is the length of the altitude. So I have h right here, but that's also known as the altitude. And keep in mind, this cylinder is considered a right cylinder, and the reason why we can say that is it makes a right angle between the base and the side. Now, in a cylinder, you have two things you need: a radius and a height. Once you have radius and height, you have its surface area, okay? Now, in a cylinder, perimeter for LA is no longer just adding up the sides, because now we have a formula for that perimeter. It's more specific because it's a cylinder and it's a circle. We're talking about circumference is that fancy way to say perimeter in a circle. So you got to remember, we're going to be using circumference, 2 pi r, to help us with perimeter. Whether the cylinder is on its side, h is still there, separating the two bases, okay? Still going to be the same things. R is the radius of the circle, h is the height, the separation of the two bases. Right cylinders, the segments joining the centers of the bases is an altitude, okay? Oblique cylinders, okay. Hey, when it's not right. The segment joining the centers is not perpendicular to the planes containing the bases. So now, my little caveat, thanks kiddo. In this book, cylinders are right cylinders unless stated or pictured otherwise, or in any of our practice problems that we will do. Okay, so keep that in mind as we're going through. Going on to our next page. Oop, sorry, little pre-calc. Going on to our next page, we now have LA, which is perimeter times height. But remember, I mentioned that perimeter in a cylinder is circumference. So now we will just have 2 pi r h for LA. You don't even have to write LA is equal to ph, but P, perimeter of a circle, is 2 pi r. And now that transforms for our surface area, because remember, surface area, we have the LA, which is 2 pi r h, and we have our base formula, the base formula for a circle is pi r squared. So that changes a little bit too. So now when I just say cylinder, those are the two boxed in formulas you want to grab right away. You don't want to worry about anything else. Now, please keep in mind, why is it circumference? This is my, first dimension in my right, and finding my rectangle here, that's my soup label. But that wraps around this space, and the circumference is the distance around the base. I have my two areas, my two yellow areas. That'll help me with my 2 pi r squared, and I still have that lateral area when I'm talking about the total surface area. So keep that in mind as we're going through. There's reasons for everything we're doing. And what's really nice about this, you just need two things for a cylinder. So now, get this stuff marked down, make that correction. I think I made the correction, but I'm not sure. I didn't make it here, so I'm questioning that I did in my notes. this is the practice test. That is a separate sheet. That was just something we went through in class. Okay. Questions? We okay with the corrections? Okay. Sliding on. Our first problem. Every time I have done one of these problems, I have written the formula. This is for cylinders. It's specific. It's SA is 2 pi RH plus 2 pi R squared. I need two things. I need pi. Excuse me. I need to know pi. I need to use my pi key in my calculator. But I need radius and height. That's it. So if I can get those things done, that'll be really good. So go ahead, get that one done. Plug them in. And we're going to do the exact answer and the estimate rounded to the 100th. So R is 3, H is 5. I pop them in. And I go 3 times 5 times 2. That gives me 30. I go 2 times 3 squared, which is 18. So I got 48 pi centimeters squared for my exact in terms of pi answer. Then I just use my calculator with the pi key, and I come up with 150.80 centimeters. Now, whether it's standing on the base or laying on a side, the dimensions are still found the same way. Go ahead, do B. Go ahead, do B. If you have questions, ask as I'm walking around. If you're at home, you have questions, there's tons of resources, but you can ask me next time we see it in class. Start with the formula all the time. And some people roll their eyes at me and go, oh, really, do I have to? Notes are for you to reread, to remind yourself what we did in each step. If you don't know or are unaware of the formula we're using and you just have numbers, you're just going to think you can shove numbers together and do whatever you want. Chapter 10, A, Chapter 10, B, Chapter 11, Chapter 12, all about formulas. Okay, it's all about the relationships with them. And some people think, oh, it makes it easier. It's not. You have to know how to use the formula, where everything comes to put in the formula, and all the notation and vocabulary. So just reread instead of refigure, and you'll be fine. Plugging in R and H. R is 5, H is 12. And now I have 120 pi and 50 pi, and that gives me a 170 pi for my exact, and then I plop it in my calculator, and I'm able to get 534.07 meters squared, rounded to the 100th. Okay, now, how can I make these harder? I give you words and no pictures. Your turn. Do 7. Words and no pictures. Sometimes you might have to draw yourself a diagram and fill it in as you read. And remember, as you read, 5 to 7 times reading a word problem is not unheard of. But since you know it's about cylinders, you're trying to get the radius and height information from the reading. Got some really great diagrams. Now remember, draw in the formula. Copy it down correctly. LA is 2 pi RH. SA is 2 pi RH plus 2 pi R squared. Remember, LA is the soup can label. SA is the soup can label, including the two bases of the can itself. Start with your formula. Plug in your R and H, because the radius of the base of cylinder is 4 inches, the height 6 inches. Pretty straight up, right in front of you. What is the surface area of the cylinder in terms of pi? So that means I'm not going to do an approximate. I'm just going to multiply 2 times 4 times 6, which is 48. 16 times 2, which is 32. I add those together, and I get myself an 80 pi. Okay. Now, for those that did the estimate, always reread your question before you finish going on to the next. Before you go on to the next, always reread. Make sure you were finding what you're supposed to. In problem 8, same idea. I've got a diagram there. Cylinder has a height of 9 and the radius is 10. What is the surface area of the cylinder in terms of pi? Surface area, 2 pi r h plus 2 pi r squared. And plug it in. I got 90 times 2 is 180. 100 times 2 is 200, so I should have 380 pi to finish things off, centimeters squared. Make sure you dress up your numbers with units. They get shy when you don't give them anything to wear. Okay, it's kind of embarrassing. Other numbers kind of chuckle. I know you can't hear it, but they do. They judge. Okay, questions. Now, that's the end of notes for 11-2. Day 2, and that will help you be successful on completing your assignment, which is just completing your 11-2 worksheet. But we're going to go on and check out notes for 11-3 day 1. Okay, and it's all about pyramids, those things that are in Egypt that have been there forever. Okay, but these aren't just square pyramids like the ones there. Pyramids are named by the shape of their base. I'm going to let you guys get this stuff down. And we will take about a page and a half worth of notes, and it's all about basic vocabulary property information. The objective, to find the surface area of the pyramid in a cone. So this is Geometry Notes 11-3, our day 1 version of these notes. A pyramid is a polyhedron in which one face, the base, can be any polygon, and the other face, the lateral faces, are triangles that meet at a common vertex. The vertex of the pyramid. Familiarize yourself with the diagram. Notice where the vertex is. The vertex is the sharp pointy thing opposite the base. And some people go, well, you know, how do you know it's a pyramid? If you sat on that, you'd get the point. It's a pyramid. Okay? Lateral edge is the edge where two lateral faces meet. The lateral faces make the lateral edge. Okay? A lateral face is a triangular face coming from the base to the vertex. The altitude on the inside is the distance from the midpoint of the polygon base to the vertex. That's its height. Okay. The base edge are the edges of the base shape. And in this one, the base shape is a hexagonal pyramid. Keep that in mind. Now you'll notice I have a little picture to the right there, a blue triangle with a red line going up. Keep in mind that if this blue triangle was a really great representation of my, lateral surface, one triangle, right? It's perfect. If I consider that fact, if I bring it back, if it allows me to bring it back, apparently it's fallen apart. It's having a breakdown. Triangular breakdown. Kidding. Notice that the red line is in the position of the height of that triangle. Okay. I want you to be aware, we still have a basic shape formula. A triangle's basic shape is base times height divided by 2. Well, this triangle is the height, this red line is the height of this triangle. That would be considered the slant height. The height going up alongside this blue line, the height going up along the side of the face from the midpoint of the base edge to the vertex. Okay, it's the height of that panel triangle. We call it slant height because instead of being upright and perpendicular, it's slanted into the point. So we just run up the middle of the face of our pyramid to do it. Now the altitude of pyramid is the perpendicular segment from the vertex to the plane of the base. The length of the altitude is also the height. Now this is about the slant height. What I just kind of discussed. The slant height, this red line, going from the midpoint of the base up the side of the triangle. Now this blue line is called the lateral edge. And we just learned about the lateral edge. And I'm going to put a green line in, and we got a base edge. Okay. We still have the height, that's the altitude. And I hope you're starting to recognize, hey, look at that H and that L, that kind of makes a right triangle. So if I'm missing pieces of my pyramid in order to do a calculation, Pythagorean theorem will be used to help me find the missing piece. So a regular pyramid has a regular polygon for a base and congruent isosceles triangles for lateral faces. Slant height L is the length of the altitude of a lateral face perpendicular to the base edge along the side to the vertex of the pyramid. That's why we call it slant height. It's along the side. Missing slant height can be found by using the Pythagorean theorem, whether it be the distance into the center with the height or using the lateral edge with half the side and the slant height. Those are two ways we can be finding the missing slant height if we need to. Now, my little side, in this book, pyramids are regular unless otherwise stated, because I'm going to be honest, surface area of an oblique pyramid is really tough to find because all the triangles are different. Okay. Now, lateral area of pyramid is the sum of the area of the congruent lateral faces. Surface area of a pyramid, add the area of the base to its lateral area. So its lateral area is just finding the area of one triangle and multiplying it by how many triangles there are in the shape, or better yet, multiplying that area of the one triangle you found by the number of sides of the base, because they're going to have just as many triangles as there are sides of the base. And then the surface area, just add in one base, because there's only one base. Okay, that vertex doesn't have any area. It just comes to a point. So I hope you get that point as well. Okay, LA is 1/2 perimeter times slant height. And really what we're doing, we're finding areas of triangles. Perimeter is this multiple triangles we are adding together. Okay, multiple triangle bases we are adding together, and then multiplying by their height, the slant height of those triangles. And then because a triangle area is base times height divided by 2, we divide by 2. SA is 1/2 perimeter slant height plus our area of our base, whatever that base is. So you get to choose your base formula, big B, based on the shape you have and the information provided. And our last screen, I think this is it before we start doing our practice problems. Oh, we'll get one practice problem, one set of practice problems in. We'll have time to do that. Okay, lateral and surface areas of a pyramid. Lateral and surface areas of a pyramid. The lateral area of a regular pyramid is half the product of the perimeter, P, of the base, and the slant height, L, of the pyramid. So LA, just like we just did, 1/2 perimeter times slant height. Surface area of a regular pyramid is the sum of the lateral surface area and the area of the base, big B. SA is equal to LA plus B. Okay, that's a general thing for pyramids, but in this case, we're going 1/2 perimeter times slant height plus base, big B. Remember, the big B is not just a number, it's a collection of numbers based on a base area you find, okay? So let's talk about that. Here, what is the surface area of a hexagonal pyramid? Okay, let's see how I've got this set up. If we're going to do surface area, I've got this 1/2 PL plus B, but remember, P is the perimeter of my base. L is my slant height. Do I have P? Do I have L? I have a base edge length. Do I have the number of sides the base actually is? They say hexagonal, it's 6. So I've got a 6-inch side, a 6-inch, 6-sided base. So it's 36, and L's 9. Okay, so 36 times 9 divided by 2. My base shape is 1/2 ANS here. Okay, so I got 36 times 9. Okay, 36, remember, is my perimeter, 6 times 6. Now, as I'm stepping through, I'm thinking base area. We're going to see how I did this. I'm skeptical. Yep, I was skeptical, and I should have been. So we're going to flip back, and I'm going to do it 1/2 ANS. So we're going to do this, that. So remember, my base shape, 1/2 ANS for my base. A is my apothem. They give me A. N's the number of sides, okay, which was 6. And the side length, which is also 6. Okay. So once I get those together, I got 36 divided by 2 is 18. 18 times 3 is 54, the square root of 3. And I got 162. Now, if I wanted to, if I asked, hey, I wanted an exact answer, this is it. Okay. But go ahead, take out your calculator. Get her done. And once you get that one done, 255.53 inches squared. Are you okay? Pretty cool, right? Go ahead and do number 2 on your own. Same pattern, same stuff. Big B, specific area formula you have to find for your base. I'm going to tell you, that's a regular pyramid with a square base. Wonder what the formula of an area of a square is. Hint, hint, hint for your big B. Start with your main formula. Start with your main formula. And I'm going to give you a hint about 20, maybe. Just like any good restaurant trivia game, I'll start revealing as we plop in. L is 6. Big B is a square, which is 5 times 5, 25. Are you okay with where I'm getting my numbers? Anybody got a question? Yeah, shoot. Where did I get the 20? What's P represent? I know, I've answered a question with a question. Where did I get the 20? But what's P represent? People? Yeah, it's perimeter. So it's perimeter of the base. So I have a base that has one length of 5, but all the lengths are 5 because it's a square. So it's 5 times 4, which is 20. Okay, does that help? Any other questions? Okay, awesome. Now, at this point, once I get to this spot, you got to think about the hardest parts that we did. We did a selection of formulas. First, it's a pyramid, so I had to select this pyramid surface area formula. That's thing 1. Thing 2, it's got a square base, so I had to know that big B was just going to be s squared because it's a square, or x squared if you wanted to look at it that way. So that was where my 5 squared came from. That's where 25 comes from. My L is slant height. That was here as we went through. Once I can identify the vocabulary and how it relates to my figure, I can put it into my formula, and I'm back in 6th grade again. I'm just evaluating those numbers using the order of operations correctly. So now I pop that in, hopefully, and I got 6 times 20, half of it, 60, plus 25, and I get 85 meters squared. And I'm not sure why I have that last one there, so maybe perhaps I got to get rid of that. But that's the end of today's notes. Okay, we did 10-2 day 2, 11-2 day 2, and we did the first part of 11-3 notes. We will be able to finish 11-3 on Friday. Any questions? Awesome. Hopefully everything's going well, and we're going to go correct our assignment, or at least the first part of it.